First, thank you to you, George, for giving me the opportunity to participate in this series of seminar. As you said, I'm going to talk about climate clubs, border carbon adjustment, and trade wars. That's a lot of things to put together. This is a joint paper written with Miguel Borrero, that is a student, a PhD student in our program. And let me to begin with first words introducing the issue we are going to analyze in this paper. The idea of creating a climate club for overcoming free riding in international climate policy has become very popular since the publication of Nordhaus 2015 paper. Let me first spend two seconds or 2 minutes just to put the context of this paper and to give a more clear motivation. That we are talking about international environmental agreements. When we look at the literature, the problem that we try to address is a very standard problem in economics. In fact, is the provision of a global public good. So we can see that the emission of one country are the contribution to a global public bad, because there are emissions, but we can change the variable. We can define abatement as emissions as usual minus current emissions, and then we can redefine the problems in a standard way of a problem of contribution to a public good. In this case, what is a transnational public good? This is the main issue that we want to address. So the question is that we want to design agreements that are able to promote a high participation in the agreement to control emissions, and moreover to be effective. It means not only the high participation, this is like a necessary condition, but we need as well a commitment for the countries to implement a strong reduction in emission in order to solve the problem. So the issue addressed in this literature is how to design agreements such that we are able to promote high participation, high effectiveness of the agreement. In this branch of the literature, we can put the paper by Nordhaus. So the first time I look at the paper, it was very interested in seeing what is the definition of a club in terms of this. There's some novelty there in comparison with the previous literature. But if you look at the paper, in fact, there's not any novelty, because for Nordhaus, a club is just an agreement. And then we can talk as a club as an international environmental agreement of a climate treaty. So there's not really a different proposal from what is in the previous literature. But there is something that is a novelty in the paper, is that he proposed to focus on a carbon price instead of focusing on emissions reductions. If you look at the Paris Agreement or the Kyoto Protocol, what you can see is that the countries negotiate to reduce the emissions. That means that the agreement must to put a target for each country in terms of what is the emission reduction. Maybe it's a common target for a group of countries, but in any case, we have to decide about what is the target for all the countries that are seen in the agreement. So in some way, we can say that we are talking about a vector of n dimensions, with each dimension is the quantity, is the emissions of each country. However, if we focus on a carbon price, all these dimensions reduce to one, because the agreement is just to put a carbon price, harmonize an international target carbon price, and then leave the countries to define the policy to implement this carbon price. So moreover, this novelty connect with a very standard debate in economics about prices versus quantities. And here is clearly a position of Nordhaus moving from the standard approach that is proposing reduction in emissions to focus on a carbon price. That's, for me, is the main novelty in the paper. Second is penalization. So he proposed to use an uniform percentage tariffs on the import of non-participating into the club region. So it's to use trade sanctions in order to promote the cooperation, to incentivize more participation. So if we now look at the results are not so optimistic. He used an empirical model, the standard model by Nordhaus, the DICE model. He used he redefined the model to use the coalition DICE model for 15 regions. And the main conclusion is that as the target carbon price rises, it becomes increasingly difficult to attain the cooperative equilibrium, a global climate club, using trade sanctions. So the exercise he proposes to consider different carbon prices, but the carbon price is given and is equal to the social cost of carbon. So we assume the social cost of carbon of $10, and then he looks at different tariff from 1% to 10%, and look at what is the participation depending on the level of the tariff. And the result is that the higher is the carbon price, the higher the social cost of carbon, the lower is the participation. So this is a result that we can find in the previous literature and has been called by Barrett and other authors as the paradox of cooperation. The paradox of cooperation in the sense that we can obtain high participation, but when we don't need high participation because the gains of cooperation are low. Or in other words, when the gains of cooperation are high, the participation is low. So that's the results in Nordhaus paper. It's an empirical paper. What we have to propose is to move forward to propose a theoretical paper to analyze a coalition formation game, taking part of the ingredients that are in the Nordhaus paper to have a more clear understanding of what are the problems associated with cooperation when we use trade sanctions. And then we propose an extension in two directions. The first is related with this proposal. On 14 July 2021, the European Commission adopted a proposal for a new CBEM, this is Carbon Border Adjustment Mechanism, which will put a carbon price on imports of a targeted selection of products. The Commission's proposal for a CBEM should prevent the risk of a carbon leakage and support the European Union's increased ambition on climate mitigation, while ensuring World Trade Organization compatibility. So there we see that instead of using this uniform percentage tariff on imports that can have problems with World Trade Organization rules, we can focus at the carbon border adjustment, because this is a mechanism that in fact plays the same role as a tariff, because as we are going to see, it has the same implication in terms of change of trade terms. So, but on the other hand, using this mechanism is more compatible with the World Trade Organization rules and can be acceptable as a mechanism that can be implemented by the agreement in order to make a penalization that in some way is admissible at the international level. Just a few days later in The Economist, we can see an article that's called Carbon Border Taxes Are Defensible, but Bring With Risk. The European Union's proposal might set off another trade war. So this is another issue that we are interested in. That is not in the Nordhaus paper. What's the problem that appear when the countries that are not in the agreement can retaliate against the agreement? So you put, the members put a BCA, and then the other non-members react, yes, making a retaliation through a tariff on the imports coming from the members that belongs to the agreement. So we want to propose these two extensions. First, a theoretical model that in this setting we are considering, instead of uniform percent tariff, we are going to consider carbon border adjustment. And moreover, we are going to take into consideration the possibility of retaliation. So they have another extension that is I want to highlight, is that usually international organizations or agencies have an important role, we can say that, in international negotiations, but are the countries that finally negotiate and ratify or not the agreement that take the final decision. In this paper, we want to move forward from this approach, given more power, but yes, between commas, because we want to give to the international agencies the possibility of presenting proposals of cooperation. So then we are considering a more active role to the international agencies in international negotiation. It doesn't mean that the international agency can implement an agreement. Obviously, it's not the case. What we are assuming is that at the end, obviously, the countries are going to implement the agreement, are going to decide if they are accepting or not the proposal, but we open the possibility that having an agency looking for a tax for a carbon price and proposing a carbon price for all the countries, and then countries will sign what we can call an adhesion treaty that give access to a climate club, but that is designed by the international agency. Designed in the terms that the agency is going to propose the task to be adopted by the countries. So the proposal will consist of a harmonized carbon tax to be applied, and the application of a CBAM to penalize non-members selected with the aims of obviously overcoming free riding in international climate policy and achieve full participation. So with this target in mind, we analyze an extension of the standard coalition formation game that incorporates a new player, the international agency, and a stage zero where the international agency announces his proposal and invites all countries to join it. And we consider two scenarios to compare then, one without retaliation by non-members and another with retaliation. So our exercise that we develop consists on giving the maximum legally enforcing power. I'm going to define this in 2 minutes, to the club members, and explore if there is a carbon tax for which the Grand Coalition is stable. Notice that if the policy is announced before countries decide on participation, the stability condition will depend on the club tax. Then we can assume that in stage zero, the international agency chooses the club tax that maximize global social welfare. That's the standard assumption. But among the taxes that eliminate the incentive to deviate unilaterally from the global climate club. That's the novelty of the approach. I will explain with more detail that later on. So the aim of this paper is to investigate if this problem has a solution, characterize their properties, and find out how this solution changes if non-signatories charge a tariff on signatories' exports. Let me to advance the main conclusion, because usually I don't have all the time. Yeah, even if I have a lot of them, usually I spend a lot of time with introduction. And then let me to advance the main conclusion, just in case. First, without retaliation, there is one and only one carbon tax for which the rank condition is stable. So we have results of persistence and uniqueness. Second, we find that in the equilibrium, no BCAs are applied. So BCAs are using as a punishment mechanism, but obviously you implement the ground collision, they are not going to be applied. But let me to elaborate more on this later. Finally, or third main conclusion, the first best carbon tax does not make the stable the ground collision. What does it mean? This tax here is a second best carbon tax. It's not the tax that implement the efficient solution. And finally, with retaliation, no carbon tax can stabilize the ground collision. So this is not a robust mechanism because just with small retaliation, as we are going to see, then we cannot get a solution for this problem. Let me to summarize in one slide the literature I have been using to prepare this paper. Well, our paper obviously is placed in this line of research, this strategic trade policy models. As maybe you know, a strategic trade policy game is a game where you have mainly two stages. The first stage, the governments decide on the trade policy with the target to maximize national welfare. And the second stage, the firms compete in the markets. There is two kind of models that are using this approach. I differentiate them between models that is supposed that they are in perfect competition in the markets and models that assume that there is perfect competition. The similar paper is by Barrett, 1997. And what Barrett did is just to introduce another stage in the game. So there's a first stage where the country decide on the participation in a international environmental agreement. In the second stage, the countries decide on the trade policy and environmental policy. Maybe countries that are seeing the agreement are cooperating in this stage. And finally, in the third stage, the firms competed in the markets. So this is the first paper. They use an international oligopoly model with market segmentation. And the results are that we can get more cooperation in an international environmental agreement that are linked with trade, just under from a point of view, very strong assumptions. They use trade sanctions, but the transaction is a ban on trade. A ban on trade, that's very, very strong assumption. And only there is full participation if like a minimum clause is working there. Let me to move to the more recent paper. And here I have to mention this paper by Mullis in 2014 and a paper by Aylan and George, two papers, very interesting ones, because obviously George is here, I have to say that, but even if he's not here, these are very interesting paper. And mainly the paper in 2014. This is a first paper where the BTA are applied. BTA is just a way to call the border carbon adjustment. Border carbon adjustment is more related with the contents of CO2 in the commodities. Here is related with the difference, the differential in the tax. So they assume that there is a tax on emissions, and the countries can put different taxes. There's a differential in the taxes, and then there's adjustment in this differential, and this is a BTA, a border tax adjustment. They analyze two country models, and I want to highlight this paper, 2014, mainly because there you can find this is stage 0 I have mentioned before. Eiland and Sakur assume that there is a stage 0 where the World Trade Organization is going to choose the adjustment rate in order to maximize social welfare. Then there is a second stage where the country decide on the taxes, and the third stage where the firms compete. So this is the first paper where I know where we can see that there's a role, a more important role for the international agencies. And the results are very interesting because they show that yes, putting this stage 0 with a power to the World Trade Organization, almost the cooperative solution can be implemented. The point is that these are 2 country models, so they don't analyze, obviously, the participation. There are other papers by Herman Smith, Alcodagian, Finus, and Diamantu et al., when they analyze N country model, and then the focus is as in Barrett, 1997, on participation in the agreement. So the idea is coming back to Barrett's approach and looking how it will link trade with participation. If we open the negotiation to include maybe some trade policy, we can promote participation in the agreement. The results here are more optimistic. They are based on numerical simulation, but in Alcodagian Finance and Diamantu et al., they can see that if you introduce, for instance, in Alcodagian Finance, you introduce BCAs, or in Diamantu, if you define a free trade area for signatories, that's promote the participation. All these papers are with perfect competition. There are no BCAs, and the results are similar to the ones obtained here. And there are more papers that are using a different approach. For instance, there's a very interesting paper in 2021 where Barrett and Dannenberg recovered this idea here, but using an experimental experiment, and they obtain similar results. When you link the participation in a trade agreement and the participation in an international agreement, you can get more cooperation, but under some constraints as to give some minimum participation. Well, a minimum participation promotes more participation, but if you don't reach this minimum, there's problems. Then we have the computable general equilibrium models that are empirical models. They have Lessman et al., Boring-Her et al., Hagen and Snyder and Nordhaus, another paper with more optimistic results. I would like just comment Hagen and Snyder because this is the only paper where there is retaliation. And they find that even with retaliation, if there is some punishment or penalization mechanism is used by the members, they obtain more stable coalition, more participation, but with a clear remark. An important remark is that in some way, what they find is that the gains that they come from more cooperation in reducing emission are compensated by the distortions that the tariff create in trade. So there is not a clear scene in terms of welfare gains there. Finally, I want to comment this paper by Masudi in 2012. This is not related with trade. It's just a paper on the stability of international environmental agreements, because he takes the idea here of having an international agency and state 0. She considers the extension of the analysis in Eiland Thakur. Here, she assumes like a four-sided international environmental agreement that, as has a first mover advantage, she takes, or the agency takes into account whether the proposal is going to make the agreement stable or not. So then the international agreement, the international agencies looking for proposals, in this case are quantities, abatements in emissions, that eliminate the incentives to deviate and then can make the uranium collection stable. So we developed this idea in a different context, in a context of strategic trade policy. And we obtained similar results, not exactly because it's not so powerful as the results in Masudi that we obtained, but similar results, at least without retaliation. Let me to move to the model. We use an intra-industry trade model with n ex-ante symmetric countries and a representative firm, a consumer in each country. Firms produce a horizontally differentiated good whose output releases greenhouse gases, which cause environmental damage. So we have a model with product differentiation. And first compete in quantities in cementing markets. It means that we have n oligopolistic markets. So all firms compete in all countries, and the oligopoly that you can see in its markets in an oligopoly with product differentiation. There are no transport costs, and before the creation of the Climate Club, the status quo is a free trade regime. Obviously, we can say that these are very strong assumptions, but we can live then just assuming a constant transport costs, unit transport costs, and some previous tariff. But this means to introduce more parameters in the model. It implies more complexity. And then we think that to assume a free trade regime status quo is a good departure point to analyze our issue. So the fourth stage came. Stage 0. The International Agency proposed the creation of Climate Club to adopt a tax, TI, this is the tax for the members of the club, and charge a BCA rate equal to 1, I'm going to explain this in 2 seconds, to imports coming from non-members countries that apply a lower tax or no tax. This is Nordhaus approach. So we have the target is a price. And second, there is some penalization for the countries that are not participating in the agreement. Stage 1, all countries decide simultaneously and uncomparatively whether to adhere to the Climate Club. In Stage 2, members adopt the carbon tax and the BCA proposed by the agency, whereas non-members select the carbon tax that maximize their national welfare, taking as given membership and the policy followed by the rest of countries. First approach, we assume no retaliation. And finally, Stage 3, all firms choose simultaneously and non-comparatively their cemented market outputs for each of the end markets, but maximizing their net benefits. As usual, we solve the game by backward induction. Let me begin with the final stage, Stage 3. Well, the model we are using is the model proposed by Al-Kubdagi and Finus as international oligopolies with product differentiation. And this is based on this inverse demand function. This is the inverse demand function in country I for the variety produced in country K. And it says that the price of the variety K in the country I is equal to A minus 1 minus gamma, where gamma is the degree of product differentiation, something that goes from 0 to 1. That's the trade from the country K to country I, and that's the total consumption in country I. Total consumption is the addition for all the varieties that are sold in the market of country I. So if gamma is equal to 1, we have the homogeneous good case. That's, for instance, Barrett's model. If gamma is equal to 0, firms act like a monopolistic for the variety in the market. And between 0 and 1, we have an oligopoly with product differentiation in each country. We denote the set of members by S. This is a subset of N, capital N is the number of countries in the world, with M, the cardinality of S, and obviously M can be something between 2 and capital N, that's the Grand Coalition. A representative member will be designated by I or K, and a representative non-member by G or L. So what we do in this stage, we calculate the quantities. And the quantities are the quantities that maximize net profits. That's the expression for the net profits for a firm located in a member country. So in stage 1, the countries decide to be in the agreement or not. So in stage 3, we have 2 types of countries. The countries that have decided to stay in the agreement and the countries that are not members. So that's the standard net profit for a member country. And then we have profits for trade between member countries. And here from a member country to a non-member country. And then the revenues are equal to the quantity times the price minus the marginal cost of production minus the tax proposed by the international agency. Here we assume that 1 unit of output generates 1 unit of emissions. So we normalize this coefficient to 1. So this is a tax on output, but obviously it's a tax or it's defined as a tax on emissions. But we relate emissions with output in the standard way with a fixed coefficient saying how much emission you get from 1 unit of output. In this case, this coefficient is equal to 1. Net profits for a firm located in a non-member country. So then we have as before here, that's member G selling to a member country, and member G selling to a non-member country. So here there is no changes, but here there is a chance, obviously, to introduce the BTA. So this is now omega, capital omega. Omega is defined in the following way. We have that the agreement applies fee adjustment rate that can be a value between 0 and 1 over the difference between the task selected by the agreement and the task selected by the non-members. Obviously, this applies only in the case that the task selected by members is higher or equal to the task selected by non-members, and is equal to 0 in the other case. So what is the maximum legally possible enforcement power? Obviously, is when phi is equal to 1. Okay, so that's the idea of saying when we suppose that we are going to study what is the tax that stabilizes the Grand Coalition, provided that the maximum legally possible enforcement power is applied, it means that we are giving here a value of 1 to this parameter. Now, what we get is the quantities. And then we have non-member markets. And here is the firm's ice variety produced in a member country exported to a non-member as market, given by 5. And you have here that the quantity depends on the market size. This is A minus C, depending on the degree of product differentiation, depending on participation, of course, and in the tax selected by the agreement and the tax selected by the other countries. They act non-comparatively, and at the beginning they can select different taxes. So then we analyze the effect of taxation on output, and we have the standard results. Here is nothing new. So let me to move to the member markets. So this is firm's ice variety produced in a member country exported to a member case market. So this is trade between signatories, between members countries. And then we can see that in this expression, you can find here phi. We are going to assume in the second stage this is equal to 1, but in the third stage, we calculate the quantities for the more general model. So assuming any value for phi and assuming any level of participation. So now what is important to highlight here is this second expression. This is France yes, variety produced in a non-member country, exported to a member case market. And that's a long expression, but notice on this partial derivative. This partial derivative is evaluating the effect of the adjustment rate on trade between a non-signatory and a signatory. And what is this effect? Well, we can notice that this effect have a different thing depending of what is the difference between taxation. So if the tax selected by the members is higher than the tax selected by the non-members, this is negative and we have a negative effect. So this is what I commented before. So the tax adjustment, the border tax adjustment play in fact the same role as a tariff in the sense that it causes the same modification in the terms of trade. An increase on this adjustment rate have the same effect on trade as an increase in a tariff. It reduces the trade of a non-member for a signatory members. So BTA can be used as well as a penalization mechanism for non-signatories. So notice that if we assume that phi is equal to 1, all the trade that goes to members, that depends exclusively on the tax applied by the agreement. So as the adjustment closes the gap between the tax, then the trade is determined by the tax selected by the agreement. So now we follow to the next step, but we do some assumption here. We make some simplification in the analysis. We are going to focus on the stability of the rank coalition. So M is equal to N. Well, this is because this is obviously a very interesting case. That's the rank coalition implements the efficient outcome. Okay. Moreover, as you can imagine, maybe some of you, the analysis of the stability of the rank coalition is easier than the stability of other levels of cooperation, because when we apply the stability condition, the external and internal stability condition to define the level of cooperation, when the rank coalition, we have to apply only the internal stability condition. So it makes the analysis in some ways more simpler. Moreover, we assume that's maximum legally the force and power for the agreement. And then what we have to do first is to calculate, or we have this stability function. That means that's the social welfare for the signatories when there is a rank coalition and the rank coalition apply the tax proposed by the international agency. And these are the social welfare if one country deviates. That's unilateral deviation. So we focus on the national equilibrium in this stage. And when deviate, the countries that are in the agreement just fix, they don't change the tax, they just adopt the tax proposed by the international agency. Right? There's not a recalculation of taxation because this is the tax that the agency proposed, and then there's adhesion treaty, and the signatories, the members, just apply the tax proposed by the agency, right? So then in stage 2, we have to calculate non-members carbon tax. To calculate this term, we have to solve this problem. It means we have to calculate the optimal tax for a non-member for the tax announced by the international agency when we have an agreement of N-1 country. Then we use the definition of the welfare and the standard partial equilibrium. We have the standard definition. We have the consumer surplus here. We have the producer surplus here. Notice that this is the trade from the non-signatory to the signatories, and then we have the differential in taxation. Here is fee, but fee is equal to 1, okay? So we are assuming a given value for fee. And here, there's just one deviation. We are comparing one country and the other countries are in the agreement. So there is the consumption of the product produced in the country I, consumed in country G, G and G, sorry. And finally, we have to introduce here the damages, environmental damages. And this is a global problem. So it means that the damages are related with total output, global output. And delta is the marginal damages, and as the function is linear, this delta is the social cost of carbon. Let me make a simplification now, just for facilitating the presentation. I'm going to follow with the case gamma equal to 1, just because the expressions are simpler. We have the results for gamma between 0 and 1, but I prefer to do the presentation for gamma equal to 1, that the expressions are not so complicated. So when we have gamma equal to 1, the consumer surplus have the standard version, 1/2 the square of the consumption in country. That's the same than before, and the damages. Now what we obtain is the reaction function. Obviously, that's the tax of the non-member depending on the tax announced and adopted by the members. And as we expected, we have a strategic substitute. So it means the higher the tax proposed by the international agency, the lower is the tax selected by the non-members. So given this tax, we made the substitution here of the best reaction function, and then we get this payoff. And this payoff depends in this way on the tax. We have a polynomial of second degree. It's not a very complicated expression. So we can write the welfare for a non-signatory when one signatory deviates from the agreement is given by this expression. But let me to clarify things. The first things we have to clarify is that in order to work with this stability function, we need to guarantee that the tax proposed by the international agency is higher than the tax selected by the non-members. Because, remember, the adjustment is applied only when the tax for members is higher or equal to the tax for non-members. So this is correctly defined just in this case, right? Because this is not the case, this is 0. So we are assuming here the case that we are putting the constraint that we apply, want to apply a BTA. And to apply to a BTA, we need to guarantee that this differential is positive, right? So there's a first constraint. That means that T must be higher or equal to this lower bound. Okay, this lower bound obviously is the intersection of the reaction function with the 45-degree line in the space of taxes. It means that if the agreement select this tax, then the non-signatories are going to select the same tax. The best response is selecting the same tax that's selected by the agreement. Moreover, you have the non-negative constraint. We have involved 4 quantities. You have trade between signatories and non-signatory members and non-members. And then we have to consider the non-negative constraints. So for these cases is a trade between signatories. And the case when we have trade between a non-signatory and a signatory country, the constraint is that the tax must be not higher than the market size, but that's standard result. Then we have here the trade between a signatory and a non-signatory. Going from a signatory to a non-signatory. To have this positive, the tax cannot be very high. If the tax that is by the agency is very high, that's going to be zero, obviously. So then you have an upper bound over the tax. Moreover, there is...
Santiago, 5 minutes if you would like to leave some time for questions.
Yeah, sorry. Okay, so then we have another constraint here on the tax, right? That must be higher than this lower bound as well in order to guarantee the non-negative constraint. So then what's complicated, but we are happy because we can order these taxes. This is the order, provide that the social cost of carbon is just below this upper bound. That's the market size multiplied by the number of countries. So that's, well, this is not a strong assumption. Okay, so then we can move to stage one, the stability of the grand coalition, and then we can define the stability function. We have already defined this, and then to define the welfare for non-signatory countries when they apply TI, it's very simple because it's just substituting the quantities in the expression of welfare. All the countries are in the agreements. So the only constraint is this constraint to guarantee the non-negative constraints on output, right? So then the stability function for the grand coalition have this expression, okay? So we have here again a polynomial of second degree, and this bar phi is positive. We have all the things here that are determined, and then we can see that the stability function is strictly concave with respect to the tax. So it means that if this equation have a solution, for example, two real solutions, then we can define an interval for the taxes such that in this interval, the coalition is stable, right? So then let me move to the key point of the paper, stage zero, second best carbon tax. Now, what is the role of the international agency? The international agency is going to propose a tax and given adjustment rate that's equal to 1. And what tax is going to propose? Obviously, that's the standard assumption that propose the tax that maximize the global welfare from the grand coalition efficient outcome that implements efficient outcome. But now, following the process in Masaudi papers, we can see that there's an international agency that is a first mover. It can anticipate things. So the question is, why to propose a tax that maybe can give maximum for that, but that this tax doesn't guarantee the stability of the grand coalition? Because if this is not the case, this tax is not going to be implemented by the grand coalition. We can maybe get another level of cooperation, but not the grand coalition there. So let me to choose a tax that maximize the global welfare, but taking into account that I want that the grand coalition be stable and full participation be the outcome of the game. Obviously, between the taxes that are feasible. So then, proposition 1, the carbon tax selected by the international agency is this minimum, this lower bound, okay? And there's just one tax there. The proof is very straightforward, very simple. So if you calculate the maximum of the stability function, then you get that the maximum for the stability function is given by this quantity, by this tax. Moreover, when you calculate the maximum value for S, you notice or you find that this is zero. So given the strict concavity of the stability function, this implies that is zero for all the taxes that are in this interval except for this lower bound, right? So let me explain a little this result in order to make the main conclusions. First, in some way, the problem is trivial because the choice set contains only one tax. I'm going to show you this in a moment with a graph. But there's another interesting result here, or this is an interesting result here. This is the following. Notice that if a country decides not to enter the club, what is the optimal tax that is going to choose? The best response is the same tax that is proposing the international agency. So the point is that the agency is announcing a tax such that the best reaction for a country that are leaving the agreement is choose the same tax. Obviously, this means that no BCAs will be applied to the country exports. And moreover, what we see is that the international agency uses his strategic advantage to induce the non-member country to select the same tax that the one proposed by the international agency. And that is enough to eliminate the incentive to deviate from the grand coalition. So what we have is that the stability function has a shape like this. This is a numerical example for alpha equal to 100, n equal to 10, delta equal to 1. And then that's the interval of values for feasible taxes. And then that's the maximum, the minimum, this minimum in the lower bound of the interval. And we have the maximum is equal to 0 for all the taxes. Then what we have is that the S0 no agreement is, the grand coalition is not stable for any taxes. Okay, so let me finish with just a few words, very short words on retaliation. What we do on retaliation? Well, the idea is to modify stage 2, and then what we are going to do is to introduce a tariff. The non-member react to the BTA and then charge a tariff on member imports. So when we calculate the net benefits for the firm located in a member country, we can see that the profits that difference get when it's selling to the non-member country is equal to the quantity times the price, net of the marginal cost, net of the emission tax, and net of the tariff. Then we do all the calculations. We repeat the exercise. And then what is the result? The result is that this curve, the stability function, moves down given this retaliation. And then there is no tax in the physical set for which the agreement is stable. So just small retaliation, because look, here we are looking at unilateral deviation, just one country moving outside the agreement, and just one country is putting a tariff on the imports coming from the agreement, and that is enough to make the mechanism not working, right? So let me finish with the conclusion. As I said before, with retaliation, there is a second best carbon tax for which the grand coalition is stable. In this case, I cannot, regardless of the degree of product differentiation doesn't play any role in terms of the stability. No BCAs will apply at the equilibrium, but with retaliation, the November tariff is a strategic, with retaliation, no carbon tax can stabilize the grand coalition, regardless, again, of the degree of product differentiation. Thank you very much.